Good evening, everyone. Welcome to this week's presentation, xLights Gems on mobile shows and how to take your show anywhere with John Darst. With that, I will turn it over to you, John. Thank you.
All right, thanks. Let me see. I think it's going to be easiest if I just share my whole screen and I'll get my little PowerPoint up and going here. So, all right. Well, first, let me thank you for joining us tonight. As Andy mentioned, my name is John Darst. I will start with telling you a little bit about myself, but this is a class for portable or mobile light shows, and I kind of phrased it that way because it can mean a lot of different things to different people. But some of the concepts are going to carry the same, whether you're wanting to create a show that you could wear, if you want to create a show that you can carry in a backpack or put on your car, on a trailer, your RV, your quad, kind of whatever you have where you want to get portable. A lot of the concepts we're going to talk about tonight are the same. So I'm not putting a solution out there. I'm just talking about the things you want to keep in mind, from power to audio to kind of the whole nine yards. Even though this is an xLights gym series, this is not an xLights specific class. It's really kind of platform generic, which is good because as some of you might know, and some people give me a hard time about, is I'm still using Lightorama. So, but what I'm teaching about applies equally to everybody. So hopefully you don't hate me too much. Um, but if you do have questions as we go, I don't see the chat, but if you do a hand raise, I think I'll see that. Otherwise, you can hold them to the end or kind of however we need to do it. So, um, that being said, a little bit about me. So I am a senior OT strategist at Kimberly-Clark, which basically means I work on machine networks for our manufacturing machines. Married with two kids. I started back in 2012 with a Mr. Christmas display and kind of have evolved from there to where I now run a 20,000 pixel show. So not huge by any means, but it works well for our yard. And then I also, as I have a picture here, do a parade truck every year. So I take my truck, I decorate it up, and I've been doing this for a few years now. Put it in our local Christmas parade. This picture that you see here was from last year. We survived the rain and did a Greatest Showman themed parade entry. So that was a lot of fun. I am all about trying to kind of, customize things. So, um, while I do have, Coro props and that kind of stuff, I tried to implement things a little bit differently here and there. And we'll talk about some of that kind of stuff when it comes to doing a mobile display and ways you can get creative. So, I do have a little disclaimer. I am sharing things that I have learned, but it might not be the solution for everybody. So, like I said, the key thing is to kind of clue in on the concepts and the things to keep in mind when you're putting a show together. And there are a lot of experienced people out there that I've borrowed concepts from. So I'm not the world's foremost expert on mobile light shows or parades or any of that kind of stuff. There's a lot of other people that have been doing this for more years than I. But they're people that I've researched and I've learned from, and I'll mention a couple of them as we go through. And then the last part is if I get some detail wrong, I apologize, but you get the general idea. So you're free to nitpick me, but you don't have to. So we'll make it through that. Okay, so these are kind of areas that we're talking about. We're going to cover power, so that's a big one. So in the way this is you calculate power, the pixel selection or the light selection, batteries or power sources. We'll talk about kind of actually building the show. Audio is an area we won't talk a whole lot about, but it's one of the often overlooked pieces of a mobile show. And then we'll talk about props a little bit at the end. So when it comes to power, there are many different types of portable power sources. So we're going to focus on generators, vehicle supplied power, or battery supplied power. So they each have pros and cons. And like I said, there's no one solution for everybody. But some things that you will talk about. And I think I got that slide out of order. But anyway, we'll get back to it. So pixel type. This used to be a kind of point of contention among people kind of starting their mobile shows. So prior to seed pixels, you basically had two options for a pixel show. You had 12-volt bullets and you had 5-volt bullets or squares or whatever, but they all used the WS2811 at the time. And when it came to that, basically what you would look at is if you had like say 600 watts available based on your power setup and whatever, and you were running 12-volt bullet pixels, even at 30%, you could get about 2,500 pixels maxed out. Now, could you realistically probably get 3,000, 4,000, maybe 5,000? Yes. We're talking kind of safe limits that aren't going to overload your power supplies, even when turned on full white. So that's kind of what I'm looking at here is full usage. Um, so 12-volt bullets, you get about 2,500. With 5-volt bullets at 30%, you get about 6,000 for comparison. So that immediately you were left with a decision of, okay, am I going with 12-volt bullets or 5-volt? And again, they each have their pros and cons. So if you run 12-volt bullets at home, and you run 5-volt bullets on a parade, then now you've got double the spares and double the batch and all the extras, and you don't want to mix them up and all that stuff to deal with. But at the same time, you get over twice as many pixels using the same amount of power. Okay. Um, Now, fast forward to the last few years, and we have seed pixels and all their varieties, the gumdrops and jelly beans and Evos and whatever else is out there. Um, and I'll throw another disclaimer out there. So I did testing with 12-volt and 5-volt seeds from your Pixel store with the dual data variety. I have heard from some other people, some of the numbers that I'll talk about in here, you're going to get a little bit of difference from vendor to vendor. Some of that could be due to the size of the wire, some of that could be due to your pixel spacing. There could be a lot of different things that impact that. So, again, take this with a grain of salt, in meaning that you might not get these exact numbers if you were to do the math on your setup, but it gives you a general idea. So, let's go here. If we look at 12-volt seeds, so my third line down, or actually, let's go to 12-volt seeds at 50%. So third and fourth lines down, get about 5,200 pixels at 100%, about 6,200 at 50%. Not a whole lot of difference. So when it comes to seeds, you're not seeing a huge reduction in power usage when you turn your power down or turn your brightness down. So, but what you do see is even on a 12-volt system, I can now get the same number roughly of pixels at 12 volts as I could with 5-volt seeds at 30%. Okay. If I had seeds available when I started, then that would have been a non-starter or a non-issue for me. I would not have gone the 5-volt route at all. I would have gone with 12-volt seeds because I could get just as many. When you get down to 5-volt seeds, it's an even stranger picture because you actually, again, depending on manufacturer and all those things that get into it, you might be able to have less 5-volt seeds than you would 12-volt seeds due to the power conversion and everything happening in the background. Um, so it kind of depends on the setup, but you're kind of in that same ballpark. So you don't see a significant jump when you go from 12-volt seeds to 5-volt. Your mileage may vary. Again, the best solution is going to be 5-volt seeds at 50%, but it's really not much different than any of the other seed varieties. Like not enough of a difference that you're going to justify swinging one way or the other. Um, so if you're sticking with your bullet pixels, then obviously 5-volt from a power standpoint is obviously the way to go. If you're open to using seeds, then there's not a significant advantage of choosing 12 volts or 5 volts from a power distribution standpoint. Okay, that's the summary. Um, so how do I figure that out? I'm not going to go through this in detail, but just in case you're not aware, this is readily available information as far as the bullet pixels go. Use 0.066 amps per pixel. The seeds, again, this is going to vary. So this is what I actually measured using a pixel tester. running various configurations. And then I verified that using one of my Genius controllers. And the current monitoring averaged out over a string of, I think, 200 pixels. Um, so you get kind of the idea. Now, again, your mileage may vary, but gives you a general idea. Then you take that and you apply the power law. So I'm going to take my amps, whatever they are, and multiply it by my voltage, so 12 volts, to come up with my wattage. And then from there, I can just divide out, okay, well, how many watts do I have available? That tells me how many pixels I can fit. One thing to keep in mind is if we'll talk about generators and using power supplies and all that stuff in a minute. Similar to your normal show, or power supplies are not always 100%, or they're not 100% efficient. They could be 80, 90%. And depending on the manufacturer, sometimes that's considered in the displayed capability of the power supply. Sometimes it's not. So you might have to scale down and say you have a 300-watt power supply on hand. It's 80% efficient. You're really only getting 240 watts out of it. Again, that varies by manufacturer. So the best thing to do is to get the data sheet for the power supply that you have, and that'll tell you specifically what the limit is on the output side of the power supply. But that only comes into play, if you're using your traditional 120 volt power with power supplies. So we'll get more into that. So I'll talk a little bit more about the different kind of power source options. But I took kind of that same math and I said, okay, if these are all my different pixel options, and just for simplification purposes, we'll clue in on using 5-volt bullets, or sorry, we'll use 12-volt bullets at 30% since that's pretty common versus using a 12-volt seed at 100%. Okay. So on a single 300-watt power supply, you can easily handle about 1,000 pixels, or bullet pixels. You can easily handle about twice that many 12-volt seeds, even running at 100%. When you kind of scale that up, if you had, say, a 15 amp outlet at your house, you might have 6 300-watt power supplies, and again, about 6,000 bullet pixels or about 12,000 seeds. Now, can you run more than 6,000? Sure. You're not running full white 100% all the time. But again, we're talking safe limits here, or conservative limits. Then we keep going over. I've got example of if you had a 2,000-watt generator. So that's a pretty decent sized generator, that somebody might purchase or have at the house for emergency backups or that kind of thing. On that, you're going to be able to run about 7 300-watt power supplies. So you stay in that same ballpark as running off like a 15 amp outlet. Even if your generator has 4 15 amp outlets, that doesn't mean you can load up 4 15 amp circuits on the same generator. So you have to look at the total load capability to be able to kind of see what you can do there. But one of the things here is you're going from your generated 120 volt AC signal, you're then sending that to a power supply to convert to 12 volts or 5 volts or whatever, and you're losing in the process. So you kind of lose efficiency on the generation side, you lose efficiency when you're stepping down to DC. So you kind of take a hit on the total number of pixels overall versus the stated wattage of generators, typically. Then if you're pulling directly off of your vehicle, okay, so say if you want to pull off your battery, or I'm not going to say like your auxiliary port or cigarette lighter, because usually those are typically limited. But if you're using either a standalone 12-volt battery or a vehicle power source, then you're really going to have to get into some things we'll talk about with considering like the size of the wiring and like what your capability is if you are running off of a power port or something like that. But all that being said, if we just kind of use 150 watts as a starting point, because that's a regularly available size like buck converter that we would use to clean up power or to convert from 12 volts to 5 volts. Those typically are about 95% efficient. So on each of those 150 watt circuits, you'd be able to get about 600 bullets at 30% or about 1,300 12-volt seeds at 100%. Okay. So How many of these little 150-watt converters you can have totally depends on how you set things up and how big you want to go. For me, I can handle more than 10 of these because I've run distributed power throughout my truck and I have multiple power ports in different areas. But on a typical vehicle, like your cigarette lighter style aux power, those are generally going to be limited at about 10 amps. So you'd only be able to run one of these off of that. But if you're wanting to do just like a little thing, that say you have like some lights on your grill or lights that run down the length of your vehicle, you can get by with, running 1300 seed pixels and have a neat little animated show that runs along while you drive down the highway. You're probably not going to do a full light show like a parade entry or something like that running off of that single 10 amp power port. But you kind of get the idea. Okay. um Now, taking those same examples, what does a typical cost look like? So if you're trying to get to about 1,000 pixels, then basically how many power supplies would you need, your power supply costs. And if we just stick with this, let me see, 12-volt seeds at 50%, that's kind of the baseline I picked here. That costs you about $330 if you wanted to buy a generator and run a single power supply. Okay. If you wanted to use voltage regulators to regulate that voltage, then you're going to get two of those. They're going to cost about $50. If you're using that from your vehicle, you're going to spend about another $50 in wiring to be able to support the two regulators, unless you have the power built in your vehicle, which you might. So you're looking all in at about $100. If you're wanting to run it standalone with the battery, then you're going to have the cost of the regulators and the cost of batteries, which might be around $80 for all-in cost of about 130. Now, the downside of this is those batteries are going to drain unless you're going to wire them into your vehicle alternator circuit or something like that, but then you've got to add in some wiring costs as well. Okay. Um, Now, if we skip down here, things are going to scale a little bit differently. If you wanted to run about a 5,000 pixel show, and we're going to run this 12-volt seeds at 50%, you're going to need a little bit bigger generator. And to be able to support like three power supplies, you might be spending about $500 all in. And then if you were going to use voltage regulators, you got about $100 tied up in the regulators, about another $100 in wiring. So about $200 to get it all set up to run off of your vehicle. If you wanted to run it off of batteries standalone, you're looking at about 260. Okay. But then again, you got to figure out something to do with batteries and how are you going to charge them and what does all that look like? So um, that just gives you kind of some ballpark ideas of what those costs might look like. Now, if you have a generator at home already that you use for backup purposes or for your other hobbies or whatever, then yeah, this might work for you and this be kind of the option that you choose to go with power supplies. And then you might keep parts common and controllers common with your normal light show and all that stuff. So if you already had that generator on hand, yeah, this might work great for you. Now there's some other considerations with generators we'll talk about, but again, these just kind of give you some general ideas. Okay, so noise can be a concern. Now, this comes from experience. So when you're setting up for a parade, especially, you get into all kinds of weird acoustic situations if you're driving through like a downtown area or a rural area or passing by buildings and you've got people standing in different areas. Um, your typical gas generators are very loud, even if they don't sound it right away. Just that ongoing drone makes it difficult to get your music heard, to be able to play over the sound of the generator. And it's really annoying if you've got people riding along with you in the vehicle. Then these old school gas generators, they're cheap relatively, but that comes at a cost, and that cost is noise and efficiency, but mainly noise. Um, so that's something to keep in mind with those. Up here at the top, I show what's typically called a generator, but this is really a battery pack with 120 volt output. Okay, so a battery generator is a little bit different. One is they're typically silent, more or less. Now they do have fans on there, so if it's hot, then the fan will turn on and keep the unit cool. But otherwise, they're pretty quiet. The downsides are you have to charge them or keep them charged when not in use, which then takes some maintenance of the batteries and all that kind of stuff. And then the other part is they're not weatherproof. So if it's raining, you're going to have to protect these in some way, which can then, so say if you put a plastic bag over it, well, now you've limited the airflow. So now it could be more prone to overheating and that kind of thing. So pros and cons to using the battery generators. The others, and I can't remember if I mentioned this later, but I've run into some people who mentioned that when running off of a battery generator, they've seen issues with different controller combinations, and basically because of the way that they generate power. Sometimes it's not necessarily clean, and you can get into kind of weird fault detection scenarios. So this might detect like a cheap Chinese junk power supply as like a ground fault, and it'll immediately shut down to protect itself. So every time you go to plug your controller in, your power supply shuts off. Now that's something you can work around. You can test in advance and make sure that's not an issue or anything, but it is something to keep in mind with these battery operated generators. The best generator solution for most people would be this one in the middle. So this like Honda gas generator. Now, not just Honda, there are other brands, but basically the newer models of these gas generators have not silent operation, but more silent. So they're a lot quieter, a lot more efficient. So they'll be able to run longer and create more power using the same amount of gas. But the key is they're much quieter than your old school gas generators. So keep that in mind. It is a bigger initial investment, but again, if you're going to be buying a generator or already have one for your home anyway, then it could be worth that investment. Um, Okay, some nuances while we're talking about power. So again, if you go with the 5 volt pixel route, that can cause confusion and limit options if you use 12 volts in your home shows. So you can get into kind of conflicts between, making sure you keep them separate and your spares and all that kind of stuff. Um, Generators use the same AC controllers that you use in your show, so that's a pro typically. Battery generators, like I said, they have sensitive electronics that can cause problems, not typically weather resistant. Oh, and your battery life reduces over time. So while you might get 2 hours runtime out of it today, you use it several times, or it sits and isn't maintained well, you might only get an hour and a half when you go to use it a year out from now. Um, Gas generators, typically their electronics aren't very sensitive. They'll just have like a breaker that could trip, but you could get into power quality concerns with cheap generators that could then cause failures of power supplies or failures of controllers or that kind of thing. Um, let's see, reiterate some things. Like I said, with generators, noise and cost can be high, but you can use it for other purposes. Vehicle supplied power from your battery potentially requires effort to wire auxiliary power, but overall, it's a very efficient solution. So you're going to have the least amount of losses. You can kind of conceal things. So basically, people don't know that you're set up for a show, but like under the hood, you've got, distributed, 10 gauge wiring to all these different areas of your vehicle, and then you can just plop things in, and keeps things clean and tidy. So it's a good, neat solution. Um, and then, like I said, with battery supply power, it's efficient, but you're limited to your battery life. Maybe that's a concern, maybe it's not, just depending on your needs. So let's talk a little bit about batteries. Batteries have three major specifications to consider. So you got your capacity, your current rating, and your voltage. And as we're talking through this, kind of keep in the back of your head the power formula. So that's your watts are equal to your voltage times your amps, because all that kind of comes into play as you're talking about batteries. We talk about capacity. So this is measured in what we call amp hours. So not amps, there's a difference. Amp hours is basically the number of amps you could continuously run in 1 hour. So if it says 1000 milliamp hours, that's also 1 amp hour. Okay. And that means you could run continuously at 1 amp for 1 hour. If it's 3 amp hours, you could run 3 amps for an hour or an amp for 3 hours, roughly. Okay. Um, so capacity defines your total runtime based on your load. Um, your load is likely to be less than the maximum load that's used to calculate wire size and power requirements. So we'll talk more about that in a little bit. And you can estimate, say, like 50% of max load, depending on how flashy your show is. So what do I mean? So we go through and we do all these power calculations. We talked about how many pixels can you put on a power supply? How many pixels can you put on a power converter? That's assuming, again, that you're running continuously at the pixel count at full white. Okay, you're probably not actually doing that. So if you use that methodology to calculate and say, hey, I've got 300 watts, okay, or I'm running at um, 50 amps, and you go out and you buy a 25 amp hour battery, that doesn't mean you're only going to get a half hour runtime, because there's other things to consider, like how flashy your show is, how consistently you're running at full white. With the 50 amp show at a 25 amp hour battery, you might be able to get 2 hours out of it. Okay. Just again depends on how much power you're actually using and then how efficient your circuits are and all that kind of stuff. Okay. So it's really hard to know that unless you actually hook up a power monitor and check to see how much you're actually using. Okay, so there's ways to record that, and we'll talk more about that. So, speaking of power monitors, you can monitor with something like I show here. You can monitor voltage, current, power, and consumption. So you can get on Amazon and buy like the one I have here on the left. You might get it with like SAE connectors already, or with bare wires, and you can hook this, say, upstream of a controller and see how much total that controller is using for its complete output. Um, or if you want to get more granular, Wally sells the same thing, but already pre-wired up with an X-Connect connector, and you can plug this into your string and see your actual power consumption. Now, a lot of modern controllers have power monitoring built in, and they're giving you a calculated estimate. If I'm personally looking at full load of what my show is, if I want to measure it at full white, or I want to measure it and see what is the peak current usage throughout my entire show, I'm going to use this one over here on the left that I put upstream so I can get a full picture of, with all of the wasted power and all of the inefficiencies and everything considered, what am I actually using. And that's what this will show you if you plug it in or connect it, wire it in, whatever, upstream of your either power distribution or of your controller, kind of whatever the case may be. So definitely a good investment if you're getting into the mobile show, because it can tell you a lot of information. And they're cheap. Like I said, the Wally's one, like $17. I think the one on Amazon without connectors is like 15 or something. So not that big of an investment, all things considered. Okay. Again, don't confuse current and capacity. So we talked about what is capacity. So now let's talk about what is current. Typically, you're going to have two different current ratings for a battery. You're going to have what's called maximum or inrush or peak current. And this is the most that your system can draw, or that your battery's capable of delivering in an instant. Okay. So not necessarily for a sustained period, but if you exceed this, then you risk either damaging the battery, starting a fire, something along those lines. So if you measure your total show consumption and you're at 20 amps, but your maximum rating for your battery is 18 amps, then you could cause damage by getting up to that 20 amps one time in an instant. Okay. Um, if you are rated at uh, say 18 amps continuous, then you might be rated at say like 25 amps peak. So getting up to 20 amps one time isn't going to cause you damage. Okay. So continuous is how much ongoing current can be handled by the battery. So if it's continuously ongoing at 18 amps, the battery would be fine. Okay, you're not going to damage it in an overload type condition uh, from that continuous power usage. Now, normally, our shows are on and off and on and off. Things are flashing and all that kind of stuff. So your continuous load is probably not much of a concern unless you go and, I don't know, put in like moving heads or something like that, and you're moving them all the time. Well, that could drive a pretty significant continuous load. All right. Um, Battery voltage is pretty straightforward, so it must be equal to or greater than the controller pixel voltage. Um, so that comes with an asterisk, of course. So if you buy a battery that's rated at 24 volts and you want to run 12-volt pixels on it, you don't hook them up directly to the 24-volt battery. You have to go through a converter, and that might be a buck converter, it might be a buck boost converter. But basically, you want to regulate the voltage down to 12 volts um, and for your show. Okay. Now, if you do get that higher voltage battery, this can go back and impact the capacity that we talked about earlier. So, for example, if you have a 1,000 milliamp battery that's rated at 24 volts, that would run, and you're running 12-volt system on it through a converter, that's going to last about twice as long as a 12-volt battery rated at 1,000 milliamp hours. Because what happens is when you take this 24 volts and you split it in half through a converter, basically you now have a 2,000 milliamp hour rating. Now, it's not exactly, again, you lose things in conversion and efficiency and all that kind of stuff. But general idea, you're going to get about twice the capacity at half the voltage. Okay. Okay. So battery types. This can vary again depending on what you're trying to do. Now, if you're talking a truly portable show and you want to like throw this in a backpack and be able to carry it around, you don't want a car or marine battery to do that. But if you're putting it on a trailer, then maybe this makes sense. Or you're putting it in your vehicle, but you don't want to tap into your vehicle power. Maybe this makes sense. With these, you can get long run times. You might get like a 50 amp hour. See down here, we got like a 300 amp hour solid state marine battery. Um, Thing to keep in mind with these is marine batteries are usually a good choice here because car batteries are not designed to be fully depleted and recharged over and over where marine batteries are. So you're going to get a lot more life out of a marine battery if you're actually running it down to zero, charging it back up, running it down to zero. Um, but then that might be your only use for it, where a car battery, you might be able to get multiple uses out of it. Okay. So just something to keep in mind. These are heavy, they're large, so don't want to throw it in a backpack. However, on the other end of the spectrum, if you want a truly portable show, a really good option is a power tool battery. So these are super light, typically have shorter run times, maybe 2, 6, 9 amp hours. But they also have a higher voltage. So typically they're at 18 volts, maybe 24. And you can regulate that down to the 12 volts, to the 12 volts that you need. Cool thing about these is they're multi-purpose and they're designed to be frequently charged and discharged. So you might already have a bunch of Milwaukee tools or rigid tools or DeWalt or whatever. So you can just add a couple more batteries to your arsenal. You've already got the chargers ready to go. You can get on Amazon and buy adapters that basically you plug into and have flying leads to hook up to your power distribution and controller, all that kind of stuff. So this is a really cool option. And you can even get those in like a panel mount variety. So say if you build a box controller, then you just plug a battery right into the bottom of it. You don't even have to open it up. And you set up your show to kind of run automatically, those kind of deals. So again, for a truly portable show, so you want to walk around the neighborhood trick or treating with a light show running on your hat and your jacket and whatever, this is a cool way to do it. Um, for kind of an in between, lithium polymer batteries would be the way to go. So you really have kind of two options of compact batteries. You've got SLAs or lead acid batteries, and then you've got lithium polymer batteries. Now, 10 years ago, 20 years ago, lithium polymer batteries were expensive, like much more expensive than SLA batteries. So it was always kind of a, is it worth it to get the lithium polymer instead of lead acid in order to get all the benefits? So lithium polymers are lighter, they have a higher life cycle. Like I said, they're a little bit more expensive, but now the difference you're talking about, like you get on Amazon with reliable lead acid batteries or reliable lithium polymer, and you're talking about a difference of $40 or $50 for a 20 amp hour battery. Not that big of a difference to just bump up here to lithium polymer phosphate for all the advantages that you get. So this is kind of what you want to look for if you're talking like a small battery where you could build like a self-contained controller. And actually, so I've done one of these, and we'll talk about that one here in a little bit for Sherry, who's on this call. So if any of y'all ever seen Sherry's wheelchair, Sherry Cohn's wheelchair that she set up with a light show, that's running off of a lithium polymer battery. Okay, so we kind of beat up power for a while. Let's talk about controllers quick. Um, any controller can work, any software will work, blah, blah, blah. You can do it with Lightorama, you can do it with xLights. xLights offers some benefit, or xLights based controllers can offer some benefits in this area. So with FPP, you can easily make an entirely self-contained show. So the one that we set up for Sherry, we added inputs to be able to trigger the show. So she's got a little remote control that she can stop and start and pause. You can run your entire show on some controllers or on a Pi, or say if you got a cult board, you run it from the Pi that's on the controller. Um, or you can run it from a laptop running xLights. If you want to be able to get in and kind of hack things and keep an eye on them and have true control over your show, sure, run it from your laptop. If you got it built and you trust your setup and you're not going to need to do troubleshooting and diagnostics, load it up on a Pi, run the show from the Pi, whether it's a single controller or multiple controllers. Um, Kind of the opportunities are limitless. Okay, building your show. Um, we talked about generators earlier. Again, that's the easy option um, because you're going to build your controller boxes or buy your controller boxes with a DC power supply or an AC to DC power supply, just like everything else running in your home. So that's the easy thing. So not really much to talk about there. If you're running off of 12 volt DC sources at a very basic level, or 12 volt or more DC sources, you're going to have your source. You're going to go through some type of voltage regulator. This could be a converter, buck boost, a buck converter. And then you're going to go take your power to your controller and then your controller out to your pixels. Mile high view. Typically, vehicles are thought to have 12 volt DC from the battery. In reality, this can vary anywhere from 11 volts to 14 volts. Voltage regulation is recommended no matter if you choose to use 5 volt or 12 volt pixels. You don't want to run your controller straight off of the vehicle source when it's running up and down 11 to 14 volts, and it varies a lot as your vehicle runs. So if you never monitored your vehicle voltage, you'd be surprised with as you press the gas pedal and everything, how much your voltage changes on the fly. And you get a lot of spikes up and down. Definitely not something I want to expose my controllers or my pixels to. Um, so if you're keeping it simple and going off of again like an aux power or cigarette lighter, I don't know how many cars these days actually come with cigarette lighters. I think they're mostly called aux power now. Depending on the vehicle, these might be rated anywhere from 10 to 20 amps, which is going to give you, if you're using seeds or 5 volt bullets, anywhere in that kind of 1,000 to 2,000 variety, depending on what your circuit's rated at. once you go outside of that and you get bigger, then say you want to run multiple controllers, you want to run 60 amps worth of controllers, sizing your wiring appropriately is critical. So running that 18 gauge wire that you have inside of your controller box, or running from your to do your power balancing or any of that kind of power injection stuff, that's not going to fly. You're not even getting 10 amps off of the 18 gauge. So what happens if you don't do this? You will start a fire in your vehicle, and then your insurance company figures out that you modified the wiring in the vehicle and you don't get a fancy new car. You end up with a big bill and either need to fix your car or drive a burned up car, which smells really bad. So uh, there's a very serious risk of fire due to undersized wiring. Even if you take, you know, you put in circuit breakers, put in fuses, that kind of stuff, and if you took the time to appropriately size those, I know you wouldn't use undersized wiring because you understand it all. But even if you did, those things fail too. So you don't want to rely on that kind of stuff to protect shoddy installs. So stranded 100% pure copper wire is recommended. Using other wires such as CCA or tinned wire will require your own research because this table is only true for 100% copper wire. Okay. So if you use copper clad aluminum or use tinned wire, pay attention when you're buying your wire on Amazon because sometimes that's buried in the description. Your ampacity levels change depending on the wire used. Okay. So talk about wire and protection now. So if you're hooking up, like say, to your battery or a battery, again, use appropriately sized wiring. You want to protect it with fuses and or breakers, and you probably want to distribute power using relays. Um, and this is actually really simple to do. So I'm kind of showing you what I did, not exactly, but just to give you a general idea. So say you got a battery, you go in, you put in a circuit breaker rated at 40 amps, which means I'm going to run 8 gauge wire. And I'm running it, so say from the battery to the protection and from the protection to my power distribution. This relay box, so again, you can buy this on Amazon. It's pretty cool because you can put this under the hood. You put this little controller box in like near your steering wheel or in your vehicle somewhere, and you can actually turn on and off your controllers. You could reboot the controller, those kind of things, while you're driving down your parade route. So you get a little bit of control of everything distributed from this box, and then hey, maybe you want to add a light bar or some KC lights or something on your vehicle. I don't know. Then you can do all that stuff here too. So you got relays, you got fuses. So these relays are going to allow you to turn on and off each output, and the fuses are going to protect those outputs. Now you do want to make sure they're sized appropriately because they're going to come in with some default sizing. You hook all that up, you're going to go out to each controller setup. So in your controller box, you're probably going to have your controller, a fuse, and a voltage regulator, and that's what's going to plug into your distributed power. Okay. Again, all this needs to be, you need to look at your sizes for your wire sizes, your capacity, what you're planning to use. There is no one easy solution for everybody. So you got to kind of take all those things into consideration as you select all your different components. Okay. Um, what's this about relays? So relays are basically how you use one power source to turn on and off a load from a different power source. So in this case, what we're doing is we've got that switch that we have on the dash. Now, it was a box with 6 of them, but basically you have a switch or 6 switches or 15 switches or whatever. Each switch is going to be wired into this relay. And when you turn it on, or basically you supply power to this relay, it's going to close this circuit. So then your battery that has heavier duty wire running through this relay takes the load and runs it across that heavier wire to your light, to your controller, or whatever. So what this allows you to do is instead of running 10 gauge wire, which is not cheap, from your battery into the cab of the vehicle and then back out and distribute it to wherever you want to go. You can use this cheap 20 gauge wiring to run it, all your control stuff, and then run the heavy wiring only where you need it. Okay, so that's why we use relays. They also offer some isolation and that kind of stuff. Um, this also can allow you to wire in an engine on signal so that everything turns off with the engine. So you don't want to forget and leave your light show running off the battery and to drain your battery overnight. Then you could insert in this circuit, hey, I've got a light switch, and then I go through um, a contact for my engine on, or maybe you need to, instead of sourcing from the battery, what I do is I source this from the auxiliary power that turns on and off with the engine automatically. So I tapped into my fuse box and I pull my power from there, go through a switch. So then no matter whether I use a manual switch or I turn the vehicle off, then it's going to turn my whole show off automatically. Now, maybe you don't want that. Maybe you want to be able to park with the engine off and run everything, and you're willing to take that risk. That's fine. All depends on personal preference. Okay. Inverter. So inverter is kind of like a generator, but can run off of your 12 volts on your battery. Some vehicles, like some modern trucks, have these built in where you might have a 2,000 watt or 4,000 watt generator built into the vehicle. But these are typically going to input 12 volt DC and output 120 volts AC. So it allows use of your regular 120 volts AC controllers. It does require high current wiring from the battery. So again, depending on the size of the generator and the current capacity and all that, you might have to run 0 gauge or 2 gauge wiring from the battery all the way to the generator. And they're pretty expensive relative to the other options we've discussed, and they're generally not very efficient. So while this is an option and can allow you to run some AC items just like a gas generator would, the big advantage is this is silent. You can permanently wire it, so it's kind of a no fuss solution. It's not efficient and it's not cheap, so kind of keep that stuff in mind. Okay, so let's dig into an example. So this is my truck. So this is a 2020 F-150. If you well, I guess most of you probably don't want to do it on your phone, but if you go to my YouTube page at Darst Show, then I actually have a full walkthrough video on there. So you can go and see kind of where all the wiring runs and kind of how I did all that. But basically, what I do is I come off the battery, go through that circuit breaker I was talking about. Okay. And then that goes through and tucked in back here by the cowl. I run across, and this is where I have my battery box, or sorry, my relay box. Sorry, I don't have a great picture of it, but it's kind of just tucked down in there. I didn't even attach it to anything. It's just sitting above the wheel well where it can't fall in anywhere. And then you kind of see these white wires. So this is marine wiring that I use to distribute power all around my truck. So I used a 10 gauge marine wire, or maybe it's 10 or 12 gauge marine wire, distributed off of each of the different outputs of the relay box. And then so that kind of comes up under here and then goes under the truck. One of them runs over here to the grill, and then the others all run to the bed of the truck. So this is where I have my relay controller, just sitting right here by my steering wheel. And then in the back of the truck, I wired in these SAE connectors. So why did I choose that? Because it was the most common readily available item to be able to use that's weather repellent, and easily attaches in with the larger gauge wiring. So then when it comes parade season, I just pop the cap, plug my controller in, and I'm not having to run wire every year. So my truck is already wired up, ready to go. So this is what my controllers look like. So this is now I'm running 5 volt pixels. So this is I think it's up to 16 volts or up to 20 volts down to 5 buck converter that's rated at 20 amps. And then this is a similar thing. So another buck converter that's rated at 10 amps. So I just kind of bought both types to play with them and see how they work. This one, the reason I use 20 amps is because I actually do some power balancing off of this one. So I can run kind of the more dense part of my show on this controller, and then I have multiple controllers set up like this to be able to run kind of the less dense areas. Okay. If you're running direct to battery, so not off your vehicle, but direct to battery, same rules in general apply. You still want to use a circuit breaker, you still want to use a voltage regulator, and you still want another circuit protection between your voltage regulator and your controller. Um, so this is an example of that box I was talking about that built for Sherry Cone. So here in the bottom, we got a lithium polymer battery. This battery goes to the circuit breaker, and then the circuit breaker goes to the uh, buck boost converter. So this regulates to 12 volts. So with Sherry's setup, we're using 12 volts. And this just makes sure that we stay at 12 volts. So even if the battery voltage dips due to the battery draining, we'll still regulate up to 12 volts until we no longer have sufficient power. And then we go through an automotive power distribution. We have fusing for all the different circuits because in here, let's see, we've got a cult controller up here. We've got a stereo amplifier. Um, and then we've got, let's see, we've got a power port to be able to charge your phone. We've got the IR or sorry, the RF button controller down here to be able to oh no, sorry, this is a relay to be able to use a push button to turn things on and off. And then up here in this corner, this is the RF interface to be able to use a remote control to turn things on and off. Got some different features on here, like we used a USB power plug to be able to show voltage. So we kind of killed two birds with one stone. And then, like I said, we got remote control, stereo amplifier, kind of everything all built into one. So you just plug in lights, plug in your speaker, load the show onto the Colt, and you're ready to go. Okay. Again, on my YouTube channel, I've got a full walkthrough video showing each component of the build and how it all connects together, if you're curious for more detail. Um, this is the power diagram for that box. So again, same concepts I talked about where you got a battery, you got a breaker coming off of it. Did do a little bit of cool stuff or a little bit different with an enabling relay here. So we could have a push button power. Then, like I said, that goes through the regulator, gets distributed. There's fusing built into the power distribution to each of the different components. And then there's your show. Okay, so this is not mine, but many of y'all have probably seen Sammy's Lights on Wheels. Sammy was one of the guys that I researched, kind of how did he do that when I was getting into all this. Check out his YouTube channel. He also has a full walkthrough. Now his setup is to the extreme. He will actually drive down the highway full, 70 miles an hour with his show running. Okay, meaning it is very stable, it's very sturdy. In the back of his truck, this whole thing, everything underneath this platform is built together. All of his power distribution, all of his controllers, and he actually uses a skid steer with forklifts to load the whole platform in and out of his truck. Like I said, he's to the extreme. It's not for everybody, but if you're looking to go hardcore, check out his YouTube, Instagram, all that kind of stuff. One cool thing that he did is he's actually got it set up where he can run his show either direct from the vehicle, like I do, off the alternator. He also has a battery bank of 4 marine batteries, so he could park and switch power to the marine batteries to run his show. Or he goes camping a lot and he can pull up to the campsite and plug into an AC receptacle and run his whole show off of the AC power. He also uses 5-volt pixels because, like me, he was kind of pre-seeds, and that was the way to get the most pixels for the least power. Okay. Okay, I said I'd talk about audio a little bit, so I got just a few minutes here. There is no one for all solution. Okay, for parades, you've got to get loud. No matter how much testing you do, you could set it up at home and think that you're blasting out the neighborhood, not loud enough. You have to be annoyingly loud to everyone to be able to overcome all the vehicle noise and all the crowd noise and everything that happens at a parade. You've got to be loud and you've got to be broadcasting in multiple directions. A single speaker sitting in the back of your truck or on your trailer, probably not going to cut it. I would suggest four speakers, so you're kind of pointing in each direction. So, like in four corners, kind of pointing forward, pointing backwards. Um, like I said, power for these, typically you're going to have AC powered setups here. So you're either going to need to run off of a generator or a battery generator. If you buy speakers with a built in battery, know that they're probably not loud enough. Like there's a couple of companies out there that make built in battery speakers loud enough for a parade, but not many. No Bluetooth, don't even try. Hardwire the speaker from your controller to your amplifier, your speaker, whatever. Don't even think about Bluetooth speakers. How many, like I said, consider your audience location. Front is most important because that's where people are going to get their attention drawn and see you coming down the road, and that's where they're going to hear you. I've learned this the hard way. I've not paid enough attention to my audience in the front. I usually focus on the sides, and I actually had some video shared with me this year where as I was pulling up, you could not hear me at all. Partly I was drowned out by another parade float. Part of it was just vehicle noise. So people, even though they could see the light show going, they couldn't hear anything and had no idea. They thought it was just, singing faces doing flashy things on the front of my vehicle. Didn't make sense at all. Um, where to get, if you invest in this on your own, it can get very expensive unless you also do DJ stuff or maybe set up at a church or that kind of thing. You can seek out DJ rentals in your area or you can borrow it. That's the best solution as long as you're careful with it or you own it already. Props, make sure your mounting is secure. You can get custom 3D printed brackets from like Inspired Light Shows or SFL Designs. Seed pixels are also a big help in this area because they reduce weight. So if you don't have experience with seed pixels, the weight difference between bullet pixels and seed pixels is huge, especially when you're talking thousands of pixels. Make sure that whatever solution you have to come up with to mount your props, you can still get in and out of your vehicle. So don't clamp your door shut and then not be able to climb inside once you've got everything mounted and figured out. Um, so a couple of tricks that I found. So if you want to put things on your doors, I found that using ratchet straps actually wrapped around the door then allowed me something I can hang props from and I can still keep my windows closed when it's raining. So then I can zip tie or use custom brackets and adapters to connect to these two ratchet straps. I use my tow hooks on the front. So this board is actually zip tied to the tow hooks. And then I put all of my weight on this little board that I built down here. And then I zip tie the prop to the front just to kind of hold it up and steady. And it's tied to the grill. So that was a pretty easy solution. Using my tow hitch on the back. Again, pretty easy solution. So it carries all the weight. And then I just use kind of ropes to kind of tie things up and keep them steady from moving. So kind of use built-in features of your vehicle to your advantage where you can. My F-150 has these old bed cleats in the back where I was able to get, they're called E-Track, and I was able to get these E-Track adapters where you can actually bolt in 2x4s. So I was able to build a framework in the back. Again, use 3D printed brackets and adapters. So like these trees over here that are on the side, I use 3D printed brackets, but they're not load bearing. Most of the load is sitting on the ledge of my bed rail, and then these just kind of help hold things steady, and they've worked well for a few years now. Okay, and that is right at an hour. I'm 1 minute shy, so that wraps it up, and now we can go to Q&A. Let me see if I can get chat pulled up.
Yeah. Thanks, Sean. There's nothing in chat.
Okay, great.
Uh, Anybody have questions for John? Or anything? That was
Thank
really
you,
good, John.
John. That was very informative.
Yeah, that was good.
Thank you, Sherry.
The Honda generators that you suggest, it's been my experience with the Honda generators that they have an inverter. Does that help or does it matter?
Um, so the inverter class generators, like I said, they're really good from a noise standpoint, and I would also expect that they're better from a clean power standpoint compared to your non-inverter gas generators. Um, I haven't heard of anybody running into problems with kind of weird electronics issues or anything with those, like I have with the battery generators. Uh, like from everything that I have heard, now I haven't used them, but everything I've heard is that that is what I would call the generator of choice, would be those inverter class generators.
That's it. All right. Well, thanks, John. That was a great presentation.
All right. Y'all feel free if you got questions. You can find me on Facebook or YouTube, and I'm more than willing to share any information I have.
Thanks again. Just so everyone know, this will be this was recorded and will be posted in the xLights Gems YouTube channel.
There's one more question about the using
Oh.
hot glue to secure wires.
If you're talking about using hot glue directly to the vehicle, I personally would never do that, but I have read where some people have had success with it, with that and with tape and with different things. But I've also read horror stories of different types of tape where the finish of the car was never the same after. So it would be a parade float, not a vehicle. Okay, then yeah, I mean, for driving a parade float, I mean, you're low speed, you're not exposing a lot of torque. As long as you're not having to drive down the highway 70 miles an hour to get where you're going, then I'd imagine something like that's going to be sufficient.
All right. Thanks again, John. That was great.
All right. Thanks,
One
y'all.
last thing, John. Sorry.
Sorry.
Magnets. So I
Yeah.
use magnets to hold my my float stuff together. I do a couple of different floats and for Christmas time, and the magnets work very well. But again, finish, you got to worry about your finish. But on mine, I don't care about the finish. So do you recommend any type of magnets?
Um, so let me give you a caveat quick, because my dumb self, my first time going through, I have to display my like company, even though I don't have company, we had to display company branding on the float. So I was like, okay, I'll get a custom magnet, whatever, and then do it on the side of my truck, and it falls to the ground
You
because
drive a
modern trucks are aluminum and not magnetic. So if you are wanting to use magnets, just keep that in mind, as if you have a modern truck, most of them are aluminum now, and magnets aren't going to work. That being said, if you can use magnets, then honestly, I would do a couple things. One is I would get the strongest magnet possible, and I would put a felt backing on it. So that you could, and you can get thin felt, so the magnet will work through it. But the reason I'll get the strongest possible is because once you put that felt backing on there, it'll usually be a little bit easier to kind of pry things off or peel them off, and you're not going to risk damaging your finish. So there's a lot of stuff on Amazon. The thing to remember when you're looking at magnets and like the weight capacity, so you get 100-pound rated magnet that's going to handle 100 pounds of direct pull. That's not going to handle 100 pounds of shear force. And shear force is basically when you say, if you hook a prop on the side of your vehicle and say it weighs 20 pounds, 100-pound rated magnet is going to slide right off, because it's shearing down the side of the vehicle. So you've got to go way above on any kind of magnet rating compared to the weight and the torque and forces that you're actually going to be applying to it. So just experiment. If you're going to go down the magnet route, you've got to experiment and test it in what I would call extreme conditions. So stronger than parade conditions, just to make sure that it's going to last.
As an automotive detailer, I can definitely agree with you that I've seen magnets destroy finishes, and I've seen every single type of car cover destroy finishes. Doesn't matter how soft they are, they all destroy them.
Yeah.
Thank you, John.
Thanks, Ray.
Are we good now? I think we're good. All right. Thanks again, John. I'm going to kill it here.
All right. Thanks.